Next, we're going to take a look at graphing the cosine function. So I have the unit circle sketched for you with those ordered pairs at the same spots that we looked at for the sine function. But remembering that cosine is the x value, we're going to fill in our chart that way. So the cosine of 0 radians is 1. Cosine of pi over 2 up top is 0. Cosine of pi off to the left is -1. Cosine of 3 pi over 2 down at the bottom is 0. And back to where we started, cosine of 2 pi is 1. Rotating in the opposite direction, cosine of negative pi over 2 is 0. Cosine of negative pi is -1. Up top, cosine of negative 3 pi over 2 is 0. And one full rotation again, we are back to 1. So graphing this the same way we graphed the sine function, labeling our axes at -1 to 1 for the y-axis, and then those quarter rotations for the x values. And plotting our points, so sine starts at 0, 0. Cosine starts up top at its maximum value of 1, comes back down to 0 at pi over 2, -1 at pi, back up to 0 at 3 pi over 2, and back up to its maximum at 2 pi. So making our nice wave, and again putting an arrow on the end to represent that it will continue rotating. And we do the same thing in the opposite direction. So notice the cosine function is symmetric around the y-axis, whereas the sine function had symmetry around the origin. It had rotational symmetry. Cosine function has reflectional symmetry. Taking a look at those key pieces of information for the cosine function now. Domain, same thing. You can take the cosine of any angle rotation. So we have a domain of all real numbers. My pen is not cooperating today. The range, same range, because the cosine is adjacent over hypotenuse, same reason that the range of sine is -1 to 1. The range of cosine is -1 to 1. The period of the function is the same for the cosine and sine. One full rotation around the unit circle is how long it takes for the cosine function to come back to its original value. And the amplitude for the cosine function is the same as well.